Today, we're going to talk about proof by contradiction. In other words, indirect proof. So, in these proofs, we need to first assume that P and not Q is true. And by assuming this and doing some steps, we need to reach a contradiction. Reach a contradiction. In our conclusion, we write P and not Q in our conclusion is false. Thus, P implies Q is true, which is what we needed to prove at the initial step. Why can we say this? Why can we say that P and not Q is false? Thus, P implies Q is true, because as you know, P and not Q in parentheses is equal to this by de Morgan's law, is equal to this, which is equal to this by the truth table. So, an example, which is one of the most famous examples, we'll prove that root 2 is irrational. Is an irrational number. Prove that root 2 is an irrational number. As you can see here, to prove it by contradiction, we need to assume that P and not Q, which in this case, we need to assume that, first step, assume that root 2 is a rational number. By the definition of rational numbers, root 2 must be equal to A over B, where the greatest common divisor of A and B is equal to 1. A and B need to be relatively prime, which is in the definition of rational numbers. This will become in handy at the later steps in this proof. When we take the squares of both sides, we get 2 is equal to A squared over B squared. And when we write it like this, we get A squared is equal to 2B squared. The right side is even, so the left side need to be even too. Since A squared is an even number, this implies that A should be an even number too. Since an even number is multiplied by an even number is an even number, but an odd number multiplied by an odd number is an odd number. We know that A is an even number, which by the definition of even numbers, we know that A is equal to 2k, where k is an integer. So, when we write it, we get 2k squared is equal to 2b squared, which gives us 4k squared is equal to 2b squared, and which gives us b squared is equal to 2k squared. Similarly, right side is an even number, thus the left side needs to be an even number too. And as we said before, similar to the case in A squared and A, B is an even number. Is an even number. Thus, we can write that B is equal to 2m, where m is an integer. So, we know that A is an even number, A should be an even number, and B should be an even number too. But at the first step, we said that A and B are relatively prime numbers. Thus, we reached a conclusion, because the greatest common divisor of A and B is not equal to 1. It is greater than 1, since both can be divided by 2. So, in our conclusion, as you can see here, since P assumed Q, not Q, P and not Q is false, we can say that P implies Q is true. Since when assume that root 2 is a rational number, we reach a contradiction. We can say that root 2 is an irrational number. Thank you.